discontinuities.
Good morning, everyone. Today, we're diving into a fascinating concept in calculus, the alternative limit. By the end of this lesson, the goal is to understand what it means, and how it differs from the standard limit, and why it matters in mathematical analysis. Let's start with the basic idea of a limit. In calculus, a limit describes the value that a function approaches as the input approaches a certain point. For example, as x approaches 2, the function f(x) might approach 5. That's the standard limit. But sometimes, the behavior of a function near a point isn't straightforward. It might behave differently from the left side and the right side, or it might not even exist in the traditional sense. That's where the alternative limit comes in. Imagine a function that jumps at x equals 3. From the left, the function approaches 2, and from the right, it approaches 6. The standard limit doesn't exist because the left-hand and right-hand limits aren't equal. However, in some contexts, especially in advanced calculus or real analysis, mathematicians define alternative limits to handle such cases. These limits use different approaches, such as considering the average of the left and right limits, or defining a limit based on a specific condition or transformation. Formally, an alternative limit can be defined using a modified version of the epsilon delta definition. Instead of requiring that f(x) gets arbitrarily close to a single value L, we might define closeness in a different way. For example, through a weighted average, a directional approach, or even a limit under a transformation like x approaching 1x. This flexibility allows mathematicians to study functions that behave irregularly or that don't fit neatly into the standard limit framework. Alternative limits are useful in fields like physics, engineering, and economics, where systems can behave unpredictably near certain points. For instance, when analyzing oscillations, discontinuities, or infinite behaviors, alternative limits help describe what happens when traditional limits fail. To recap, a standard limit describes what a function approaches as x nears a point. When that standard limit doesn't exist, an alternative limit can provide a new way to interpret the function's behavior. These alternative definitions expand the power of calculus, allowing us to analyze more complex and realistic mathematical models. That's the essence of the alternative limit, a creative extension of one of calculus's most fundamental ideas. Keep exploring, and you'll see how these concepts connect to deeper mathematical theories.
Discontinuities.